Hi everybody, welcome back. This is Unit 1, Lesson 4, and we are in our note packet, Section 4. Section 4 allows us to describe matter, and matter is described basically by its properties. I know you can't see me today because I realized my head was in the middle of the screen yesterday, and I don't really know how to get rid of my head, so or at least move my head. So I'm just not going to record my face while I'm doing this, and that's okay as long as you can still hear me. So matter is described by its properties, and properties can be one of two types. They can either be chemical or they can be physical. So let's talk about what physical properties are first, and then we'll talk about chemical properties. Okay? Physical properties are used to describe the appearance of matter or even the behavior of matter. They can be observed. You can observe a physical property without changing it into something new. So you can identify maybe what color something is, or how big something is, or what temperature something is. Even things like melting and boiling point are examples of physical properties. So let's write some of those physical properties down here before we move forward. So things that are physical properties might be color, texture, size, shape. I know someone said, I think Justin said in class today that the candle, quote unquote, was cylindrical. Okay, so shape. Even things you wouldn't expect, like melting point. Okay, melting point, sorry I was interrupted, that's also a physical property. So you would think that melting would be a chemical property. A lot of students think that because it sounds very chemistry-like. But the temperature at which something melts can be observed without changing that substance. All it does is change the phase, and a phase change is a physical change. Okay? So list a couple more physical properties, and then we'll move on to chemical properties. The big word with chemical properties is the R word. Chemical properties describe how matter reacts with other matter. They describe its ability to change into another substance. So for example, rusting is a chemical property. Rusting is really the reaction of iron with air. Rusting is really iron reacting with oxygen. If something doesn't rust, plastic doesn't rust. What that would mean then is the plastic doesn't react with the oxygen to create rust. Okay, so even the lack of reaction is still a chemical property. Rusting, decomposing, like decomposing flesh. Except I can't spell that word. When something decomposes, it definitely changes into a new substance. Decomposing flesh is not the same flesh. Decomposing milk is not the same as regular milk. If you've ever accidentally taken a swig of the milk past the due date, you know it doesn't taste the same. It's been changed into a new substance. So rusting, decomposing, oxidizing, burning. It's a busy place here today. Those are all examples of chemical properties. So here are some more examples if you didn't get many listed for physical properties and chemical properties. Notice the ability to be magnetic is a physical property. The ability to conduct heat or electricity. Density is a physical property. Boiling point, we mentioned many of those. Whether or not something is flexible. Okay, being able to catch on fire, flammable, burning, oxidizing, decomposing, rusting. I think we have some of those. Okay? So many physical properties of the elements that you will need to have reference to on the periodic table are found in reference table S, as in SAM. Okay, so you may want to make a note that many of the chemical and physical properties are found on table S. And so you'll see here on table S, the melting point, boiling point, density, and some other ones of various elements. Okay, So I'd like you to take a look at this question. It says, which statement describes a chemical property of hydrogen gas? And I'd like you to write out the question, and I'd like you to write out an answer. And this will be your entry slip into class tomorrow. Okay? So write out the question and write out your answer. What statement describes a chemical property of hydrogen gas? Just to see if you understand what a chemical property is. Okay, moving on to section 5 in our notes. It says changing matter. And matter can be changed. It can be changed really one of two ways. One way it can be changed is physically. And a physical change simply alters the appearance, but it does not change the identity. In a physical change, no new matter is made. You have, at the end of the physical change, the same substance you had at the beginning of a physical change, like cutting your hair. That's an example of a physical change. Or dissolving salt in water. You still have salt, you still have water. They're just mixed together. That's a physical change, okay? You may also change matter chemically, and a chemical change is a change that does alter the identity of the matter. You make something new in a chemical change, and we'll talk about examples of both of those now, okay? So some examples of physical changes, and you can write these down in your notes. Include melting, boiling, cutting, freezing, condensing. If you don't know what these words mean, we will talk about them in a later section. Dissolving. Those are all examples of physical changes. Mixing. A chemical change are really kind of same thing as chemical properties. You make something new. So burning, rusting, decomposing, all those ones that we listed before. Baking. Baking is a chemical change. Anytime you bake something. Burning, decomposing, baking, rusting. Oxidizing. If you take a bite of an apple and you leave it sit on your table, the apple will turn brown. That's an example of oxidizing, and you've actually changed the chemical makeup of the apple. Okay, so the outside is not the same. It's actually sweeter. When a banana bruises, that's actually a chemical change. There's a buildup of sugar that is present in the bruised area, which is what makes it brown. Okay, so these are examples of chemical changes. You know the big difference between a chemical change and a physical change because there are indications. Usually chemical changes are associated with large changes in temperature, so it usually, when there's a chemical change, there's a large release of energy, so it gets very hot. Some might view that as an explosion. Okay, whether it's on a small scale or a large scale. If it's a slower chemical reaction, for example, like if you add baking soda and vinegar together, another indication of a chemical change may be present, which is bubbling or fizzing. You're making something new. And of course, having something in the container that you didn't originally have to start with, right? A good indication of a chemical change is there's new stuff made. You know, that brown stuff wasn't on your apple before. So there's new stuff made in a chemical change. So in tomorrow's lab, we're going to be mixing different things, and at each step along the way, not only are we going to make good qualitative and quantitative observations, but we're also going to be identifying if what we do is a physical change or is a chemical change. So it's important that you're able to recognize each of these. That's it for tonight, everybody. Have a great night, and we'll see you tomorrow. Happy Friday. Bye-bye.